Hi student, this is Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center Navsari. Welcome back to the lecture of digital control and its application. In last session, we learned about to finding the step size and to finding the quantized level. Okay, we just take some of the glimpse of the last lecture. In last lecture, we take one signal as a sinusoidal input, okay, and we take the samples from that signal, okay, and then we have learned to find how the number of quantized level will be achieved and how the number of step size will be achieved. And I hope in last lecture you all guys are learned to how to do those two things. Okay, now in this lecture we are focused to find out some important terms, that is known as index value, and second term, that is the quantized magnitude. Okay, how those two values will be found, we will learn it step by step. Okay, now we will take the index value I. First we will take the equation of index value I. Okay, this is the index value, that what I just write it down over here. Index value I is equal to x minus x min divided by delta. Okay, so x, that is the value of sample signal, x minimum, that is the minimum value of that sample signal, and delta, that is equal to the step size. Okay, then next value, that is we are going to be interested to find, that is the quantized magnitude. Okay, that is the quantized magnitude. Okay, and it is denoted as xq. So xq is equal to x min plus I into delta I, that is the index value. Okay, so these two term we are going to be find out, and it is very important to convert the signal from analog to the digital data. Okay, so now next we move towards the next slide so you can understand it better. You can see over here, that is first we learn that is quantized level, then we learn about the step size, and these two equation, that is I stands for index value and xq, that is stands for quantized magnitude. Those, with help of those equations, we are forming one table. Okay, how to form those table with the calculation, we will understand step by step with taking one example. Okay okay now we proceed with an example. Okay, let's take one sample x which is having the value of 0.707. Now how the value of x will be taken, I will show you in this diagram. So for the value of x, we will taking the first sample over here, the value of x which is nearby 0.707. We consider it as 0.707 for our understanding. Okay, so value of x, that is 0.707. This value of x we will put in the equation of index value I. This value of x we will be put over here. Okay, and then we are able to find the value of index I. Okay, how it will be proceed, I will show you. Okay, now over here what we do have a value of x. Okay, so which is 0.707, and we are interested to find out the index value I. So for index value I, we have the equation of round of x minus x mean divided by delta. Now we have all the values of those terms, so we just put those values in place of that. X, that is 0.707, x mean that we have -1, and the delta, that is the step size, we already found out, that is zero point 0.5. So over here we will get the answer of 3.414. So now we have to take the round off value of 3.414. So this value is below 5. So that's why round of this value, that equals to 3. Okay, so for the first sampled value, we have the index value I is equal to 3. Okay, so what found we found that the index value for this first sample value, that is I is equal to 3. Okay, so we have to repeat those steps for each and every samples to finding out the index values. Okay, for each and every samples to finding out the index values, and repeating those equation and take the different sampled value signal, you will get the 6 different index value, and then those index value we will put into the table. Okay, then after finding the index values for each and every samples, we are proceeding towards the xq, that is our quantized magnitude. Okay, now we have to find the quantized magnitude for each and every samples. You can see that is the xq quantized magnitude, the equation of xq, that is x mean plus I del. Okay, so how it will be find, we will once again taking the equation for xq and see how it will be work. So we have the equation for quant sorry we have the equation for quantized magnitude xq is equal to x mean plus I, that is index value, and del, that is stands for the step size. So value of x mean, that is -1, plus index value for the first sample we found out, that is 3, and step size remains for the same, that is the value of step size, that is 0.5. So the answer of that is 0.5. So value of xq for the first sample, that is 0.5. So in here as well, we have to find out the xq for each and every sample. We have to find out the xq, this is our xq for each and every samples with the equation of x mean plus I delta. So once again I will repeat, we have to repeat those equations for the all the samples for I and xq. So we will get one value for each and every sample, and after getting this value we can prepare one table, and this table is useful to convert this analog signal into the digital signal. How this table can be formulated and how it will be helpful to us, we will just see how it will be useful for this. Okay, we just see this slide. This is just taking the example which I already shown to you, that is for the x is equal to 0.707, that is this sampled value, and this is value I put in this equation of index value, and I will get the index value for 3 xq. The answer of xq we will get 0.5. So repeating those two equations for each and every samples. Okay, so after finishing this procedure we can formulate the table like this. Okay, the table which I am talking about, you can see there are mainly three values. One, that is sample value, index value, and quantized value. So putting the values in this equation, we can formulate this table and we will get these values one by one. You can do the practice so you can understand it better. Okay, so how this table will helpful to us to prepare this analog signal into the digital signal conversion, we can see over here. Okay, so in this slide we will see how this table will help us to translate this analog signal analog signal into this quantized signal, and after this quantized signal how will be move towards this digital data. Okay, so this procedure we will understand step by step. Okay, so now we can see for the sample value 0. Okay, so for the sample value 0 and the quantized value 0, that is over here. Okay, that is the sample value 0 and this is the quantized level 0 we are talking about. Okay, so we just start from this 0 for the sample value 0. Okay, so we will start over here, then we will take the next sample value, that is the 0.707, which is over here. Okay, this for this 0.707. For that value we have the quantized value of 0.5. So quantized level of 0.5, that is over here. So we just extend our signal to the first quantized value 0 to the second quantized value 0.5. Then after we can see at the magnitude 1 we will have the two values 4 and 1. But what happened at that magnitude 1, we don't have any quantized level. Okay, because we just take 2-bit data over there, so we just have the four number of quantized level, that is level number 1, 2, 3 and 4. Those four level is up to the point 0.5 quantized value only. Okay, so we cannot proceed for that magnitude 1. So what we do, we just take the next value of index value, that is in place of 4 we just take that is at 3. Okay, so and for the index value 3 we will get the quantized value of 0.5. Okay, understand? So for the next value of 1 we have to further extend it. It is just like that. Okay, the third sample value, once again it is at the 0.707 and which is having the quantized value of 0.5, so it will be extended further just like that. Then next it is 0, so it will be just like this. Okay, once again you proceed forward. For the 0.707 you have the quantized value of minus zero point -0.5 which is over here, so you can see we can extend it for that 0.5 quantized level. Then it will be go for the minus 1 which is having the quantized value of minus 1 which is over here, so it will be extended like that. So how it will be formulated you can be understand very well. Okay, so next what we have to do, what we have to learn, how this digital data will become. Okay, I will show you how this digital data will become with very simple explanation. Okay, now first of all we will see at the quantized level 0 and the index value, that is the 2. Okay, so for in quantized value 0 over here, that is the 1 0. So for the quantized value 0 the data is 1 0. Okay, further we will move towards the quantized value of 0.5. Okay, so this is 0.5, 0.5. So on the line of quantized level 0.5 it is 1 1, so over here it is 1 1. Further we can see once again for the 0.5 that is 1 1. Then you can see 0.5 is once again it will be 1 1. For over here 0 it will become a 1 0. For minus zero point -5 it will be a 0 1, and for minus 1 it will be a 0. Okay, so how this digital data will come you can understand very well. Okay, so that's how this analog signal we will be sampled like that. Then we will get this quantized signal like that, and from that quantized signal we will get this digital output. This digital output will understand by our computer system, and this data further we will feed to our computer system and it will be proceed for our desired output. Okay, so finally we can see this is the complete method where we translate sampled signals into quantized signal and quantized signal into the digital data. I hope this lecture will make you understand how the quantization will be done on the analog signal and how the digital data will be get for the input of the computer system. Okay, thank you very much.